Hello everyone. So let us start the next topic of climatology today. Today's topic will be the temperature of the atmosphere, and it's a very quick topic. Since we have already done insulation and heat budget, then now we have to see what are the modes of transfer of heat through the atmosphere. So let us begin. All right. So the temperature, how it is defined. Now, when we have to discuss about the temperature of the atmosphere, we have to understand first what is heat, what is temperature, and what are the different modes of transfer of this heat. So, if we look for the diagram of the atmosphere, so in this diagram, you can see the various layers of the atmosphere. The If we start from the Earth's surface, the first one is troposphere, stratosphere, mesosphere, and thermosphere. And on the right hand side, you can see how the temperature variation occurs in the atmosphere. So, here, if we go from the Earth's surface till the uh, tropopause, so this is tropopause. Tropopause is the envelope of air that separates its troposphere from the overlying stratosphere. So here you can see that there is a constant decline in temperature. Okay. After the tropopause, the temperature remains almost constant and then it again increases. So the upper stratospheric zone, it has higher temperature than the lower stratospheric zone. Then, as we enter the mesosphere, so this is the stratopause. Stratopause. After stratopause, there is again a decline in temperature, and then after mesopause, the temperature almost remains constant in thermosphere. So this variation of the temperature in the atmosphere I shall be discussing in detail once we do the layers of atmosphere and their heating. Now, let us first discuss a few fundamental things in this. Before this, let me add a few slides and then explain a few things to you. So, first of all, as I had already told you, how to differentiate between heat and temperature. Heat and temperature. All of you might be aware that heat is basically the energy, while temperature it is the measurement or of the intensity of energy. So heat may be defined as the quantity of energy which is present in a substance, while temperature it is the intensity of energy. Temperature measures the intensity of energy. So temperature will determine whether the direction of heat flow will be into an object or from an object. Say for example, we have two objects. So this is normally in the color notation, red color is used for the objects which are hot or warmer and have higher temperature, while blue color may be used for the objects which are cooler. This is a general notation. So now if this blue color object, this is cold or of low temperature, while this red color object, it is warm or has high temperature. Now this will define that the heat flow will go from this warm object towards the cooler one. So this is normally the flow of energy, the direction of flow of energy, that it flows from higher energy to lower energy. So if an object has uh, less amount of energy, it will be having the low temperature. If an object has high amount of energy, it will be having high temperature. It's a very common thing. Now you may worry, or you may ask the question like, what is warm? You know, what is a high temperature? So you all know that if we have a glass of water at a temperature of 25 degrees Celsius and a glass of water which is boiling at a 100 degrees Celsius temperature, then in this case 100 degrees Celsius temperature is warmer or at higher temperature or has more energy, heat energy, than the 25 degrees. Now if we have ice at minus 40 degrees Celsius and we have water at minus 3 degrees Celsius, then of course minus 3 will be warmer than minus 40. So the heat flow will be from here to here. So if I'll tell you a very interesting fact. At around 3.5 to 3.2 million years ago, there was a glacial event which was known as Northern Hemisphere glaciation. You will read about it if you read the quaternary geology and the climate of the past. So during this event, in the northern hemisphere glaciation, the entire Arctic, it got covered with ice, and it was so huge that this ice, it progressed towards the lower latitudes. That is why it is called as the almost entire northern hemisphere was covered with ice. Now if the entire Arctic Ocean was covered by ice, then why don't we find the ice there now? What is the reason? The reason is that ice may have a temperature of minus 30 or minus 40 degrees Celsius, right? And what about the water? Water which is below that ice. So if this is the ice cover on the top, this is ice cover. So it is floating on the ocean, right? So this water over here, this liquid water, it is liquid because it is having higher temperature than this ice. So if this water, the water of the Arctic Ocean, Arctic Ocean is at, let us suppose that minus 4 degrees Celsius, ice is at minus 40 degrees Celsius. So which is warmer? Definitely the minus 4 degrees Celsius temperature is warmer than minus 40. So the transfer of heat which was going from the water towards the ice which was on the surface, it melted it. It melted it. This is the reason that even though Arctic and Antarctic both are poles, but Arctic is an ocean. Therefore, Arctic does not have permanent ice cover. Now, places like Greenland, Iceland, Laurentide ice sheet, these are there, but the Arctic Ocean is not covered with permanent ice cover. While Antarctica, it is a landmass, so it has permanent ice cover. This is one of the main reasons why Arctic remained, ocean, because it was water. Water has a higher temperature than the ice, while the Antarctica being a continent, it developed the permanent ice sheet. Okay, so uh, temperature can also be called to be temperature. It is the measurement of available available or sensible heat in a system in a system. Now we all know that the uh, uh, objects, let us say this is a system, okay, they all consist of molecules, right? These molecules are in constant motion. They are vibrating. So they may be in contact motion, constant motion, they all are. Now, how much movement they will do will be dependent on how much heat they have in the system. So, the temperature can also be known as the measurement of average kinetic energy of motion of molecules. Motion of molecules. So, this is what you should remember, that the heat is important, and then the what is then heat? Heat in terms of energy can be defined as the total energy of molecular motion in a substance. Total energy of molecular motion. So the certain molecule may have its own kinetic energy, its potential energy. So if you add it up, it will be called as total heat, while the average kinetic energy, it is called as the temperature. Now, once a system gains some heat, it tends to transfer this heat. So what are the various types of processes of heat transfer? There are three main processes: conduction, convection, and radiation. Now, if we look at these three processes in smaller classes, that is why I have put very simple diagrams, that in the smaller classes in the science book, you must have read that if two objects are in contact with each other and you start heating this object, you give temperature to this object, then the objects which are in contact with this object, they will also get heated up. This is the mode of heat transfer, mainly in metallic solids. Metallic solids, they transfer heat through conduction. That is why we say metals conduct heat. So while the conduction is going on, you may have these molecules which are in contact with each other. So what they will do, they will, if first molecule gets energy, it will keep on transferring its energy to the other molecule which is in direct contact. That is why I say energy is transferred by direct contact, that is the conduction. Now, conduction also occurs through molecular movement, but then they have to be in contact. The heat flows from the warmer to cooler part of the body until, so conduction will go on until this whole system has uniform temperature. So let us say that this object, first object, has temperature T1. So it will keep on transferring its heat till all three have the similar temperature. So this whole system, it will conduct heat until and unless the last part of the system also gains the same temperature. So the temperature has to be equalized. Now the ability of substances to conduct heat varies in direct proportion with the heat conductivity of the substance. So let me again add a few slides and tell you. So here, the ability of a substance to conduct heat, to conduct heat, it is directly proportional to the heat conductivity of the substance. So it is directly proportional to heat conductivity. Heat conductivity. Now, what does this mean? It means that there are few objects which can be called as good conductors, say for example metals, while a few objects which are the poor conductors, non-metals, right? Now, if you remember, we can explain this as the metals. The metals, they have free electrons in them, free electrons which do movement, which are free to move. So what do they do? If in this system, if this is a metal, so those free electrons, they keep on moving, they keep on jumping. So in this process, they transfer the heat to the last molecule. But in case of non-metals, this facility is not available. So they cannot conduct the heat. Now, it also depends on the difference in temperature between any two bodies. If if the temperature of two bodies, let us say, are T1 and T2. Let us suppose that this temperature T1 is 100 degrees Celsius and temperature T2 is 90 degrees Celsius. Then the rate of heat transfer heat transfer is slow. It will take time to equalize. But if T1 is, let us say, 100 and T2 is 10 degrees Celsius, when the difference is large, then rate of heat transfer will be very fast. Is fast. So it means that the time taken for heat transfer is also proportional to difference in temperature. Difference in temperature. If the temperature is difference is high, heat transfer will be fast. If the temperature is difference is less, the heat transfer will be slow. But then this conduction, it is not a very important process as far as the atmospheric heating is concerned. So it is an insignificant process, insignificant process as far as atmospheric heating is concerned. Because we all know that in the atmosphere there are non-metals and gases, which non-metallic gases, which are poor conductors of heat. So this process is not very much useful when we study the atmospheric heating. Second process, which is very very important, and it is the main process, is the convection. Now, convection is the process. See, energy is transferred by mass motion of molecules. In previous case, they were in direct contact. In convection, there has to be the movement of the mass or substance from one place to another. Now, we will discuss convection in detail because convection is the main process by which the atmospheric heating takes place. So what happens here is that the convection is the transfer of heat through the movement of mass or substance from one place to another. So it involves the transfer of heat by the mass motions of the medium through which the heat is transferred. Say for example, if this is a bowl in which you are going to heat some water. Okay, this is the heat, and then there is water in this vessel. So on heating, what happens is, we all know that cold water, cold water is heavier than warm water. So what does this mean? It means that it means that this this portion at the base, it will be cold, while at the top of it, at the top of it, this portion will be relatively warm. Now what will happen? As you provide heat to this base, so the water which is in contact with this vessel, it will get heated up by the conduction process because it is in contact with this. Once this water gets heated up, now we all know that water is a sorry water is a volatile substance. So what will happen? This water which gets warm will now become lighter. Okay, so it will start to move up like this, and then the water which is relatively cold, now the surface water is cooler than this rising water, so it will start coming down. So this is the mass movement wherein this we all are aware that such type of cells, they are called as convection cells. Convection cells. So what two processes were going on over here? At the base, conduction happened. Conduction heated the water, and then convection cells were formed, and then this process will go on till the entire system gets heated. So interestingly, this process is possible only in fluids, that is liquids and gases. Therefore, convection is the most important process for heat transfer in atmosphere. Okay, now heating and cooling of the atmosphere, it involves two processes: advection and then of course convection. So while the atmospheric heating has to take place, so we have seen three processes happen. Let me add more slides. So what did we see? We saw that if let us say this is the Earth's surface, then now this is the solar radiation which is coming in, and then it gets converted to long wave. So this will be short range and this will be long range or long wave. So this radiation, what does it do? The air pocket which is close to the Earth's surface, this air pocket gets heated by conduction. Now, as they get heated, they are volatile, they start to rise, they start moving up. Along with it, as they move up, they will transfer their heat. So let me draw it by red color. If they move up, now they will transfer their heat in a vertical fashion, in a vertical manner. Okay, so this is the rise of this warm air which was close to the Earth's surface. So rising warm air. Okay, now as it rises, it gives its heat to the nearby areas. Also, it goes horizontally. So there are two motions. There is a vertical motion which we can safely call as convection, while there is a horizontal movement also, horizontal movement which will be called as advection. So both, so what did we see? We saw three processes: conduction, that warms up the earth's surface, the air near the earth's surface, and then by convection and advection, the atmospheric heating takes place. Therefore, the process of convection is extremely important. What was the third process? Radiation. Radiation. So the energy is transferred uh, as electromagnetic radiation, and then it is a transmission of energy from one body to other without the aid of a material medium. So you there is no need for the objects to be in touch, or there is no need for the mass transfer. It is simply the movement of the a transfer of heat, okay, that is in the form of electromagnetic radiation. Now we all know that all bodies they radiate energy, and earth, it does black body radiation. I hope you all know about what is black body radiation. If not, please read about it. Okay, so the uh, this amount of energy which is going to be radiated by any body will depend on the temperature of the radiation. So radiation is directly proportional to the temperature. Okay, so how much energy is radiated will be depending on the how temperature of that body. Now what happens here is that the radiation is one of the three mechanisms that we have just seen, but still I would say that convection has more role in heating of the atmosphere than the radiation, and therefore the entire heating of atmosphere takes place through these three processes working together, wherein convection has a major role. So I will stop this lecture for now, and then in the next lecture we will be discussing about the heating and cooling of the atmosphere. If I take this entire topic in one go, the video will be too lengthy for you and it becomes very boring. So try to read about it, and if you have any doubts and questions, please ask me. Okay.